In this video, we're going to be learning about numerical patterns. A numerical pattern is any time you're seeing a repeated operation going from number to number in order to make a series. First, I want to introduce you to a couple of different pieces of terminology that we use. First of all, every pattern always has a rule, and it's pretty self-explanatory what a rule is. It's the way that you tell which number comes next in the series. The numbers in a pattern we describe as terms. The first number in your pattern is called your first term. So in this particular pattern, you can see that our rule is +3. We're starting with 4. So I'm going to go from 4 to my next number. That's +3. So that's going to be 7. And now 7 plus 3 is going to be 10. 10 plus 3 equals 13. You don't have to draw these arrows in the +3 each time. You may just be able to tell that the next number is 16. And after that, if I wanted to continue, came 19, and so on and so forth. And actually, I should be writing down that you'll often see an ellipsis drawn at the end of a pattern, ... to show that this pattern is a continuing one. So here's an example of an addition one. I can certainly do them with subtraction also, but here's one where we've got multiplication. So I'm going to use my same strategy. My first term is 2, and my rule is times 2. So that's going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and in case you were curious, the pattern would continue with 64, 128, 256, 512, 1024, 2048, 4096, and that is as far as I can go. Maybe you can go farther, though. Sometimes you'll find that you have a two-step rule. So, for example, right over here, our rule is +8 minus 2. So I'm going to think about this. 5 plus 8. Oh boy, well 5 plus 8 is 13, but then I have to do minus 2, and that's going to be 11. So let's go on now. 11 plus 8 is going to be 19, but minus 2, 19 minus 2 is 17. And you keep on going. Now, you might notice that there's another way in which we can describe this rule. +8 minus 2, well, that's the same thing as just saying +6. So if you can find a shortcut rule, you're absolutely welcome to use that strategy. 17 plus 6 is going to be what? Hold on one second. Is going to be 23. And 23 plus 6 is going to be 29. And our rule continues and goes on and on and on. Sorry, my watch is telling me it's time to pick up the kids. Sometimes you'll notice that you'll have a rule that's telling me that, you'll have a pattern here, but we haven't been given a rule. So you're given a couple of terms here, 3 and 9. Well, I know that 3 times 3 equals 9. So it could be 3 times 3 equals 9. 9 times 3 equals 27. 27 times 3, and it keeps going and going. But what else could this rule be? It could be it could be times 3. But from 3 to 9, based on the information I've been given, it could also just be +6, in which case my next number is 15. My next number is 21, and so forth. So whenever you have to figure out a rule, it's best that you're seeing 3 different numbers in the pattern so that you can be sure that, okay, from 3 to 9, that's +6. From 9 to 15, that's +6, so that you can be certain of what the rule is. So let's say we were given 3, 9, and 15. We know that the rule is +6, and then you just keep on going. 15 plus 6 is 21. 21 plus 6 is 27. And again, the pattern goes on and on and on. So rules could be a really interesting thing to kind of have some fun with, to figure out. As long as you know the rules and the first terms, you can figure out the pattern. Sometimes you're going to have ones going backwards. And I actually didn't even make one for this, but let's do it really quickly right now here. Let's do my rule. My rule is going to be Let's just make an easy one, plus 2. And maybe I have 30. So now I have to work backwards. Well, I know that to get here is plus 2. So to go backwards, really what I have to do is figure out my inverse operation, and that's going to be minus 2. So 30 minus 2, because I'm going back. So I've changed my operation from addition to subtraction. 28. 28 minus 2 is 26. 26 minus 2 is 24. 24 minus 2 is 22. And it's really important that when you're working on something like this, you're checking it over, because kids tend to get mixed up on which rule they're doing. Oftentimes, kids would look at this and they'd say 32, 34, 36, 38, because the rule is plus 2. They forget that. So it's always important to check it over when you're done and to look and say, okay, my rule is plus 2. Well, 22 plus 2 is 24. 24 plus 2 is 26. 26 plus 2 is 28. 28 plus 2 is 30. Yep. Okay, I've checked it, and that works. So there are a lot of neat things that you can do with numerical patterns and rules, and I hope this video helped you to understand some of those strategies right now. Have a great day.